Keypad is a 3 by 3 grid with the digits 1 to 3 in order on the top row, followed by 4, 5, 6, then 7, 8, 9. Fred has the keypad upside down, rotated 380 degrees. You can imagine just turning your page around. We're going to get 9, 8, 7, 6, 5, 4, 3, 2, 1. And then he types his 4-digit PIN as if the keypad were the right way up. So let's say his PIN was 7, 5, 3, 1. He would actually then be typing 3, 5. That would stay the same. 7, 9. Now we're told that the number he types turns out to be 2025 more than k times his original PIN, where k is a positive integer. Prove there's only one possible PIN and find it. So let's say the original PIN is A, B, C, D. I'm going to write it with a line over it to kind of show it's in digit form rather than us timesing A, B, and C and D together. Now, what happens when we do the rotation? You got it. That's the key bit of the question, really. Actually, the pairs always add to 10. We essentially, if it was A, it's now 10 minus A. And if it was B, it's now 10 minus B. That is the transformation to go from any one here to here. So my new code is going to be 10 minus A, 10 minus B, 10 minus C, 10 minus D. These are my 4 digits. Okay, and now we can form an equation because we can write this just like I can write 7,531 as 7,000 plus 500 plus 30 plus 1. I can do the same with A, B, C, D. It's going to, although I'm told that the number he types is 2025 more than k times his original PIN. So I'm actually going to start with the right-hand side. So it's going to be 1,000. Just like it was 1,000 times 7, it's going to be 1,000 times 10 minus A plus 100 times 10 minus B plus 10 times 10 minus C plus 10 minus D. Okay, that is my number in like powers of 10 form. And that is k times the original PIN. So k times 1,000 A plus 100 B plus 10 C plus D. Then it's actually 2025 more than k times. So I've got to add that on as well. And there we go. Got an equation. This is a Diophantine equation. Okay, so although it looks like there's so many unknowns, we've got to remember that A, B, C, D are whole numbers, and K is a whole number as well. And furthermore, A is actually restricted. A, B, C, D, I'm just going to write that down. A, B, C, D are between 1 and 9. Okay, so that's a big restriction as well. So let's expand the equation out. I'm going to get 10,000 plus 1,000 plus 100 plus 10. 10,000, sorry, 11,110. Then I'm going to be minusing 1,000 A and 1,000 B. In fact, I'm just going to say that I'm minusing all of this added together. And then that is going to equal K. Okay, I'm not going to do much with the right-hand side for the moment. So what I can now do is combine these terms together. I'm going to be adding this onto both sides, and then I can actually factorize it out. So 11110 is actually going to equal k lots of this plus 1 lot of it. It's going to be k plus 1 lots of 1,000 A. Plus 2025. We are getting somewhere. I'm now going to minus that 2025. There's different ways to do this. We might do the subtraction like this, do a lot of sort of exchange or borrowing. Or you could maybe minus, I don't know, I'm just going to minus 10 from both. And then minus 15 from both. And that just makes it a lot easier to do. I can see now, if I've got 11,000 and minus 2,000, I'm going to get 9,000. So it's going to be 9,085. This is a crucial part of the solution. Now, one thing to say, remember, a is greater or equal to 1. So k plus 1 is going to have to be less than or equal to 9, because I've got something that's at least 1,000 in here. And what I can do now is work out the prime factorization of 9,085. Doesn't seem too easy to do, and actually we don't need to do the whole thing, but we can see that 5 goes into it. So let's just start with that. That goes into it 1, remainder 4, and then 8, 1, 7. So 9085 equals 5 times 1817. And then I can see if I've got any other prime factors. So 2, it doesn't not divisible by 2 because it's not even. It's not divisible by 3 because the digit sum is actually 17. It's not divisible by 5. It doesn't end in a 5. And if you try out 7, that doesn't work as well. We get a 2 here, get a 5 here. 7 doesn't go into 67. We'd end up with 9 remainder 4. So no prime factors less than 9 go into 1817. Therefore, since k plus 1 must divide into 9085, you can imagine dividing both sides by it. And we've got not the prime factorization, but we've got a factorization, and we can see that no number between 1 and 9, well, sorry, 2 and 9 go into 1817. K plus 1 must equal, well, 1 or 5. So k must equal 0 or 4. We can reject that one because we were told that k was a positive integer. So the only consideration is k equals 5, which implies that our number A, B, C, D must then equal 9085. Sorry, I said k equals 5 there. I meant k plus 1 is 5. K is 4. Um, we can divide that then by k plus 1, which is 5, and that gives us the 1817. That is going to be the only pin that's possible. And let's just check it out to finish. So it's going to be 1817 times 4 gives 7268. I then add 2025 to it, get 9293. And if we kind of then look at look back at here, 9293, we can see that it is the 1817 when it is when the keypad has been rotated. This is 1817. Okay, well done.